Yeah, you were going to write characteristics of polynomials. Characteristics of polynomials. And we are going to type negative x to the fourth plus x to the third plus 2x to the second. And we are also going to write it. Okay. And then go ahead and graph. Now, when you look at this, it's pretty zoomed out. You guys see that? It's pretty zoomed out. So if I want to really focus in on the part of the graph that has stuff going on, I can see that's kind of like between x values of like -3 and +3. You guys see that? And I can really see that the y value, 1, 2, 3, 4, it goes a little bit higher than 4. So what I'm going to do is I'm going to maybe do from -5 to +5 for the x min and x max, and then -5 to +5 for the y min and the y max. And I'm just going to do that because that's going to help me zoom in. And what I'm going to go ahead and do is I'm going to draw a sketch of that off to the side, because we are going to be labeling our sketch a little bit. So it kind of looks like this. So what are some things that we typically find for characteristics? We've been doing this for a lot of units now, so yes. And behavior, all that stuff, right? So on this one, we are going to ignore vertex and we're going to ignore transformations. We don't really have a vertex. There's not like a middle point for these ones. And with transformations, we don't really have that. We don't have that like special form. So we're going to kind of ignore those two characteristics this time. But we're definitely going to find things like x and y intercepts, domain and range, increasing and decreasing intervals, end behavior, all that normal stuff we're going to look for. So let's go ahead and do the x-intercepts first. All right, so I've got, how many x-intercepts do I have? 3. We've got one right here. We've got one right here. We've got one right here. Did it? Oh, it's kind of there. It's kind of there. Hi, guys. Hi, guys. Oh.
That's a problem.
If I'm looking for x-intercepts, what do I do? So how do I do that? Second trace, option number 2, and I have to do left bound and right bound. So for the very first one, I'm going to do my left bound a little bit underneath the line, my right bound a little bit above the line. So left bound, right bound. At this point in the year, you should be able to find x-intercepts really easily. That should no longer be an issue. You should be able to get them, okay? Option number 2. So our first x-intercept is -1, 0. And if you need to, go ahead and write second trace number 2 next to that so you don't forget how to do it. We have this one right in the middle, and some people's calculators, I think, are okay with doing left bound and right bound, but some people's calculators, like I'm pretty sure mine doesn't like it. But I think I've had some people whose calculators were okay with it before. Yeah, so really, but if you look at the table on this one, you can see that there is an x-intercept at 0, 0. You guys see that right here at 0, 0? Okay, so we do have an x-intercept there. If I were to give you a problem like that in a testing situation, it would be one that would be relatively easy to find. I'm not going to give you one at a funky decimal, like, haha, I got you guys. I'm not going to do that, okay? But the other one we can definitely do left bound, right bound on, so we're going to do second trace, option number 2. We're going to scroll over and find the last one over here. So left bound, right bound, 2, 0. Okay. Now, I have seen some people who hit the trace button and then just try to get as close as they can. No, we don't do that, okay? Those are not good estimates. We don't do that, okay? So if you can't do it the actual way, you need to come ask me, because you need to be able to do left bound, right bound, and find the real answer, not just make a good estimate, okay? Make sense? Okay. So we found the x-intercepts. We also want to find the y-intercepts. How do we do that? Yeah, we already found it on this one, but normally how would we do it? So we would do second trace, not option number 2 this time. Which one do we use? Option number 1, and we plug in 0. And so option number 1, plug in x equals 0. And for this one, an x-intercept happens to also be the y-intercept because it's where the 2 lines cross. Yeah. Okay. We're also going to find maximums and minimums. So polynomials are interesting. We've had a lot of graphs that didn't really have maxes or mins, or at least if they did, they weren't very interesting. Polynomials, we finally get some interesting answers for the maxes and mins, okay? So this graph actually has 2 different maxes. There's a little mountaintop right here, so we're going to look for a max right there. And there's a little mountaintop right here, so we're going to look for a max right there as well, okay? So if you look at your calculator, we're going to do second trace, and then which one do you think we're going to go for if we want to find the max? Number 4. Okay, so I'm going to write that on my notes. Second trace, number 4. And it does, we're doing number 4 for the maximum. It does left bound and right bound. So if the top of this little mountain is the middle, then the left bound would be slightly to the left of the mountain, and the right bound would be slightly to the right of the mountain. So if I think that that is where my answer is, then I should go to the left of it and say, okay, there's my left bound. If that's the top of the mountain, I need to go to the right of it. There's my right bound. And then let the calculator find it. Okay, now I need you to do this. I need to hear clicking on your calculator, and I need you to find the max, and it needs to be exactly the same decimal as mine. You should not have a different answer. We should have the same answer, so you should not be tracing. You should be getting this actual answer. So the decimals that I got were negative 0.693 and then 0.397. You should have got that. The very last decimals could be different, but the first 3 should be the same.
I got 6.9300.
That's what I got.
So maybe I didn't go over far enough. Let me double check. Okay, so here I'll go over a little bit further to be more careful. Left bound, right bound. If you went too high, it probably found a point over here. Negative 0.693. Yeah, that's fine.
Yeah, that's what I got.
Yep. What it means is I didn't go over far enough. Yeah. Negative 0.69. Dang it. 3, comma 0.397. Okay. And then we're going to do it again for this one over here. So second trace, option number 4. So if my mountaintop is right there, then I'm definitely to the left side of it. And this would definitely be to the right side of it. So make sure that when you plug it in, you can get the same answers as me. Are you typing it? Checking you got the same answers? Yes?
Yes.
Okay. All right, so let's go ahead and write both of those on the papers. I went ahead and labeled them, but I'm going to go ahead and write it next to Max anyway. So negative 0.693, 0.397, and 1.443, 2.833. Most people do not put a U in between an X and a Y coordinate and another X and a Y coordinate. They only put the U in interval notation when you're talking about from one X value to another and then from an X value to another X, okay? But this is an X and a Y coordinate, and so we would just say and. I have one answer and another answer, okay? The U is typically not used. It's an and, that's my and sign. Okay. Next, we have a little valley right here. Does everyone see the little valley? Okay, so that's the min. We're going to do second trace. It's probably 0, 0. I'm just going to do it just in case. And also, it's good practice. So second trace, option number 3 this time. Again, I'm going to make sure that I do my left bound and my right bound. So left bound, right bound. Ah, this is perfect. It doesn't say 0, 0, or does it?
Mine says 7.6.
Yeah, look at this, look at this.
Mine is negative.
Yeah, okay, what does the E mean?
To the 10.
Yeah, times 10 to the negative 6 power. So let's go back to scientific notation. Let's think about our science classes. So if I have, I'm going to write down what mine said, okay? It said negative 1.36 E negative 6. You'll see in 1 second that ours are actually exactly the same. So this means negative 1.36 times 10 to the negative 6, right? And this is 3.702 times 10 to the negative 12. So let me do a little scientific notation real quick. That means I take my decimal and I move it 6 places to the left, right? So what I really have is negative 0.12345 comma. And this means I take my decimal and do what with it? 12 places to the left. Okay, point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 3702. That's essentially 0, 0. My calculator is struggle busing this afternoon. Okay, so, and your calculators did the same thing. If you look at it, everybody who thinks they have a number, you don't. You have 0, 0 in scientific notation with a really weird decimal that's essentially 0. It's just your calculator's having a hard time. I want you to write 0, 0. So when you see that, you have to pay attention. Now, most students, if they were not paying attention, they would have been like, oh yeah, that's totally negative 1.36 and 3.702. Except if you look at the point, it's clearly at 0, 0. Okay, that's clearly not left 1.36 up 3.702, right? That's a silly answer. Do not ever tell me E on your test. Don't you dare write down this answer, okay? You need to be able to look at your calculator and say, okay, my calculator is struggle busing. That meant 0, 0. That is the actual answer, okay? So if you wrote this in your notes, scribble it out, scribble it all out, and write 0, 0 as your answer. So our minimum is at 0, 0. Yeah. Right. Oh, yeah. And especially don't write E if it was calculator inactive and you were cheating using your calculator. So that's the reason why we could all get different answers, but they're technically the same, is because it was just our calculator struggling. Okay. And the reason we had different decimals is because we probably all went over slightly different amounts to the left and right. Okay. All right. So some other things we want to find is we want to find the domain and the range. So we want to know how far left the calculator or the graph went and how far right the graph went, sorry. So if you look at the picture, left and right, what do we see? Negative infinity, positive infinity, so domain is easy. Polynomial functions, they are always going to have the same domain. I'm still going to ask you. It's just going to be easy points, okay? The range is a little bit more interesting on this one. It's not always more interesting, but it is on this one. So how far down does it go? Negative infinity. How far up does it go? The maximum, the highest maximum. This is the highest point that it has. Do we use the x coordinate or the y coordinate? The y coordinate. Now, even though this is an estimate, I rounded that number. Even though it's rounded, we put a bracket. Okay, because you can actually put your finger on it and say, yep, that's the highest point right there. Okay, so we're going to say negative infinity, not 3. We're going to put 2.833 bracket. If you put 3, I will mark you down. Okay. Too much rounding. Too much rounding. Yeah. Okay. What we do next is we're going to do increasing and decreasing. And as you can imagine, these are not the easiest increasing and decreasing intervals we will have ever found. So the graph looks like this, right? So I have my little stick figure dude. And what is he doing first? He's increasing. And what is the value right here? What is the x value right there? Negative 0.693. Okay, and then what is he doing? Decreasing. And what is the x value right here? Okay, and then what is he doing? Increasing. And what is the x value up here? The x value, 1.443. And then what is he doing over here? Okay, and what are these two x values? Yeah, negative infinity, infinity. Okay, so the increasing answer is what?
Negative 0.693. And then that union with 0 to 1.443.
Okay, and the decreasing interval?
Negative 0.693 to 0, and then 1 point union with 1.443 to infinity.
Why don't you do any brackets?
Because increasing and decreasing, if I was to cover up everything except for the point, I couldn't tell if that point was slanting up or down. So no brackets because I don't know if that point is part of the increasing or decreasing. Technically, we would say the point is part of neither, because if you think about, like, if this little guy had a sled with him, if we said increasing was when he was like sledding uphill and decreasing was when he was sledding downhill, at the very top, he's not sledding up or downhill. He's like completely horizontal for a second before he tips over. Does that make sense? So we would say he was increasing and then he's completely horizontal without tipping. And so it's not increasing or decreasing. That's what we would say at that point exactly. Yeah. Okay. Does that make sense? Increasing, decreasing. So for these problems, it's going to be pretty important for you to find your maximum and your minimums first. And why is that important? They help you for the range, not really domain, but they help you for the range, they help you for increasing, decreasing. So if you have a problem that asks you to find the increasing and decreasing intervals, it's like a 2-for-1. I'm making you find the max and min anyway. Does that make sense? Like, you have to do it. You can't do the increasing and decreasing without finding the max and min. It's just not possible. Okay. We want to see if the graph is continuous. Can you trace it with your finger? Yeah, so we're back to some of like the easy ones, right? This is continuous. We also want to do our end behavior. As x goes left, y goes down. As x goes right, y goes down. So left is negative infinity, down is negative infinity. Right is positive infinity, down is negative infinity. So there's our end behavior. Okay. Is there anything else that I forgot? Okay, so this assignment is not meant to be difficult. It's just taking what we've done 4 or 5 different times already and applying it to a new situation. I would say the increasing and decreasing answers are definitely different than what we've seen before. Lots and lots of decimals today. And then max and min answers are actually interesting today. They haven't really been interesting in the past. Today, they're actually going to be interesting. Okay. Any questions on this? If you cannot find X-intercepts or Y-intercepts today, you have to come sit by me and we have to do it together, because we are not tracing on our calculators. We are doing left bound and right bound, okay? Your decimals have to be accurate to 3 decimal places. Some of you guys can only get accurate to 1 decimal place because you don't know how to do it. And you've been getting marked down on every single test so far. You don't get marked down again, okay? Make sure we actually know how to get the answers to 3 decimal places, okay? All right, so I'm gonna go ahead and hand out the assignment. We have 20 minutes. We're gonna see how far we get in 20 minutes, and then I'll let you guys know what homework is, okay? Oh, definitely. So let's go ahead and type the first problem. You can leave it zoomed in if you want, or you can zoom back out. I'm going to go ahead and change it back to -10. 10 again. Or what was it? Zoom 9?
Zoom 6.
Zoom 6. If you hit zoom 6, that brings it back to a normal window. So here's the faster way. Do you guys see how it's on the left side? If you do second trace, option number 2, instead of scrolling, you can just tell the calculator the answer is somewhere between -10 and 0. Would you agree? It's on the left side. I can type for left bound. I can type -10 and press enter, and then press 0 and press enter, and it will just go straight to it. Same thing as normal. Still second trace number 2. But instead of scrolling, you just type the number. So -10, 0. And it's just way faster. So see how it says left bound, and normally we would scroll and press enter? Instead of scrolling, just start typing. Type a number. Do second trace number 2. I think you're doing number 1. So if you do number 2, you can type in -10, and it says x equals -10 for left bound. And then for right bound, I'm going to press 0, and then it goes straight to it. You press enter to get it to say right bound. And then for the other one, it's somewhere on the right side of the screen, so I can do between 0 and 10, and it goes straight there, and I don't have to sit there and wait for it to scroll, because it's kind of slow, right? You can do that for your maximums and minimums as well. So if you can tell that like the max is in between like 2 and 3, or like 3 and 5, you can type in like 3 to 5, and it will look for it for you. So the more comfortable you get with your calculator, the faster you can do these things, but that's one way of getting a little bit faster about finding your X-intercepts. Do I need to show it again? Yeah. So over here, if I do second trace, option number 2, just like normal, instead of hitting the left arrow, I'm just going to type -10, and then I'm going to press enter. And then instead of scrolling to the right, when it says right bound, I'm just going to press 0. So I'm telling my calculator the X-intercept is somewhere between -10 and 0. That's what I'm telling my calculator. And then if I press 0 one more time, it says guess first. I'm going to ignore the guess. And then it gives me the answer. So you ignore the guess like normal. So it's still left bound, enter, right bound, enter, ignore the guess, and then answer. It's still the same order, you just don't scroll. Will you bring me your calculator?
How do I get it back to that?
It says float. Now you're multiplying it instead of subtracting.
Oh, I am.
You did this minus instead of that minus, and it makes a difference. So if we do second trace, 0,
And then you enter.
-10, 0. There it goes.
Yes. Exactly. There must be 4.
So second trace, 0. Negative 10 is the left bound. 0 is the right bound. Ignore the guess. There it is. So second
No, there are 5 maximum, but there are 4 complex.
0. Sure. Type
Yeah,
negative 10.
maximum. Because when it's exactly to 1,
enter 1 more time. There it is.
you do the highest.
And then for that one, you could be like 0 to 10. So second trace, 0. Left side is 0. Right side is 10.
Must be.
Fine. Or you could be like, oh, it's between. Looks like it's between 0 and 1. Like you can be more specific if you want.
Okay.
But I do that when I'm going fast and I don't want to wait for it to scroll.
Yeah, mine was like when you hit the enter again, it just went away and it took it back up.
Yeah, it would do that. It would do that if you'd accidentally hit number 1. And if you did negative 10, 0, press enter, and then nothing.
Okay.
So it might have been that.
Okay, thank you.
So, do you know how to do it for like for an exact part, so it only goes between those two on the y-axis?
So this is first. So this means you're looking at something else. You're doing intersect
Okay.
instead of doing what I was teaching you guys to do. So you can do intersect. If you want to use intersect to find the x-intercepts, you can. You just have to put 0 there.
Okay.
Is that how you've learned how to do it before?
No, actually, I haven't learned.
Okay.
So what were you telling us?
Okay,
You were telling us
so
to do
second trace, option number 2.
I can get that to work. So so 0.